Rajas, you want to say something?
So it was by mistake.
Okay, thank you.
Okay, so I'll just share my screen now. Okay, so we'll more or less continue from where I left off. All right. So, mm, so let us. So we saw some what do you call function hazards. So, so one difficulty with function hazards is that can't really do much about them because those are inherent to the function, and the hazards those hazards are inherent to the function, so you can't do much about those function hazards. So let us look at what you call logic hazards. So I hope this function hazards here. So do you have any questions about this function hazards which we had covered last time? Those of you who are present, do you have any questions about those? Are you okay with those function hazards? Yeah. Are you okay? Srijan, are you okay?
Yes, sir.
Yes, sir. All right. Okay. So let us just carry on with the. So look at this logic hazards. Okay. So this one, I don't know whether I did it last time or not, but this is the simplest. There's a just a minute. Okay. I think. Yeah. Okay. So these are your logic hazards. So look at this. Look at the Carnot map of this function. So look at the. See, I think the onset and the offset. These are you know how to recognize those. So the onset is marked with ones and the offset is marked with zeros. So if you do a simple Carnot map optimization for this, you'd cover this onset terms with the cubes shown in red. Is that okay? First of all, do you agree with that? Yeah.
Yes, sir.
Yes. Okay. So, but now you consider this transition shown in this shown with this arrow. So what is this transition? This transition is happening from which minterm to which minterm? It is happening from A bar oh, this one is that plus plus. Oh, I have actually opened this. How do I handwriting? What is the can you help me? Actually, I have not used this hexagonal plus plus before. If I just want to,
Sir, you have to choose stroke recognition in the line drop down menu.
one second. This one.
Yes, sir.
Oh, stroke recognition. This one.
Yes, sir.
Okay. Let me just see if it works. Okay. Oh, I think I'll have to make it thicker. This is really thin. How can I make it thicker? Okay, this one maybe. This is, I think this is slightly better. So this is A bar B, and this is yeah. Okay, this is CD. All right. So this is this Q. Let us say M1. Oh my God. This is a little awkward for me really. And M2 is this is B and CD bar. Oh, sorry, I made a mistake here. Oh, no, sorry. This is, sorry. This is again A bar B and CD bar. All right. So these are the two cubes. Okay. These are the two cubes. So you have a transition from M1 to M2. All right. So, by the way, that is okay. So this M1 M2, this is also called a transition cube. All right. This is called a transition cube. And say if this is represented by literals L1, L2, or let us call this literals and if M2 is then this transition cube is This is the transition cube. So just verify whether it works out this way. In fact, it does work out this way, isn't it? So if you consider the transition cube here, so what is the transition cube here? It works out to AR BC. This, well, I just write in a different. So this is the transition cube. All right. This is one, of course. Okay. So this is your transition cube. So what you find is that this transition cube, so this, I'm just drawing it a little big over here. Oh, this one is not so convenient. How do I go to a new page? How do I add a new page to this? Do you know how to add a new page to this? New page after. All right. So I'm just drawing it a little big. So that cube M1, M2, I'm just drawing that cube a little big. All right. So there are two parts in this cube, right? This is M1 and this is, and you find that this cube is, so you have a transition like this. So let me just, so this is a transition, right? You are having a transition from here to here. So, and you have, it is covered by a cube like this, and it is also covered by a cube like this. Now what you find is that it is actually covered, but, so this is, let us say C1, and this is C2, right? And if you see the realization, it will be something like this. Yeah, you can have you also have C2, all right? So in other words, this C1 is an AND gate of something. So in this case, C1 is basically, so what is C1 here? In this case, C1, if you look at this Carnot map, it is A bar B D. And C2 is D C D bar. Alright, this is C2. So basically this one is one AND gate. This is another AND gate. And these two are going into this OR gate. Right? There could be other things coming into this OR gate also. I mean, I'm just showing that like this. Alright. So what happens is when you have a transition from C1 to C2, when you have this kind of a, let's just see. So what is happening is you've got a transition from C1 to C2. So what is happening is that, you know, say this is on. Let us just say that first, you know, say this is on, and this one goes off. All right. This is your transition. This is C1 is on. All right. And here C2 is on. Now in this period, you can have a glitch. Alright, in this period you can have a glitch. There is, so let us just extend this a little further. So in this period you can have a glitch. Why? Because here C1 is on, C1 goes off, C1 is on, C1 goes off, again, alright, so this is your glitch. Alright, this is your glitch. And what kind of a hazard is this? Can you tell me, can you recall? What kind of a hazard is this? Yeah, anyone? This is a static 1 hazard. Right? This is a static 1 hazard. It should normally be 1, but because, so what is happening is this cube is switching off and this cube is switching on, but in between such a, you know, such a gap is possible. It may not always happen. So, I mean, why it may not always happen? Because sometimes it may happen like this. So you still have a glitch here. So the all of this will be, you know, it may be a little like this. So this one is what you call a strong one, weak one, and again you have a strong one. Okay, so this is so because it's a strong one and a weak one, it's not exactly a, so this one is not a glitch, but this is a, you can say, disturbance. This one is, you could call this a disturbance. This is a disturbance, but not a glitch. Okay. But this one is a glitch. This one is a glitch. Alright. So I hope you understand how you are getting that glitch, right? Is this clear to? Is that clear to you all? Anyone has a problem with this? This is the part I am focusing on. Alright. So, yeah, all. Are you okay with this? Varun?
Yes, sir.
Yeah. Someone was trying to say something. All right. So this is a glitch, and so can we solve this problem? So actually the solution is also shown over here. So the solution is that, you know, instead of having this kind of a gap, what is shown is, sorry, let's just say, oh, not magenta. Let's say instead of having this kind of a gap, say if you have an extra cube here, alright, that is exactly what is shown over here. This extra cube. Alright, so this is an extra cube to remove the glitch, which is shown in, this is an extra cube. Alright, so I think it is quite obvious that if you have this extra cube, you will not have that glitch. So basically, if I can show the behavior of that extra cube also over here. So because of that extra cube, I'll probably have it like that. This is because of that extra cube, I'll probably have something like this. So now, so this is actually the cube C3. So in this case, what is this cube C3? Cube C3 is A bar B. Class statement. Class statement. So this is A bar B C. Alright, so by including this extra cube, I'm able to, you know, I no longer have this gap. This gap is filled up, as you can see. No gap. Let's see. All right. So that is the very basic understanding of, you know, hazard. So this one is really a 1-1 transition, because M1 belongs to the onset, M2 also belongs to the onset. But the earlier, you know, the realization, if you have a realization with only the cubes shown in red, then you can have that glitch. If you add to that the cube shown in green, or now blue also, then you no longer have that glitch, because the extra cube remains on throughout the transition. Alright, so that static one hazard is avoided. Alright, so but this is not the only problem. So there are other problems. The hazard-free design is a bit troublesome. So now let us look at this 0-1 transition, which is shown over here. Okay, so this is the 0-1 transition. Look at this diagram, because this is in 2 pages now. So this is the, by the way, these slides are also there in WBCM. You can open them on your own computer or laptop or whatever. Okay, so this 0-1 transition, if you see, so it is, so just to be clear, this is M1. And this is M2. So your transition as before is from M1 to M2, alright? This is the transition. Now, when this transition happens, something interesting goes on. Alright, so let me explain that. Let me draw it bigger, as I had done before. So what you have is, let me just draw it bigger. 1, All right. So this is 0, this is 0, this is 1. And let us say that our coverage was as before. So let me just choose let us say this is 1 cube. This is another cube, and this is another cube. And your transition is happening from here to here, okay? Your transition is happening from here to here. All right. So, of course, as you can see, it will not happen directly, but it will actually go. How will it actually happen? It will happen either like this, or it will happen like this. All right. So this is the way the transition will actually happen. It will either go through this, from this minterm to this minterm to this minterm, or from this minterm to this minterm to this minterm. Assuming, you know, if you really magnify the times, you know, the time scale, then let us assume that the bits don't change together, so there is a slight difference. Okay, bits don't exactly change at the same time. All the bits don't change at the same time. So some bits, so I'm just saying that, you know, in reality, the bits don't change exactly at the same time. So maybe one bit will change, maybe one bit will change here, maybe, yeah, maybe another bit will change a little after that, and maybe another bit will change still later. So this is, you know, this is highly magnified. In practice, you might think that they are changing at the same time, but there are some differences, you know. They don't change exactly at the same time. There is a slight difference. All right. So that way, this transition. So maybe, you know. So this represents 1 cube, input cube. This set of values represent another cube. This set of values. So this is say M1, this is M2, and this is intermediate. All right. So there's an intermediate midterm. All right. So that is exactly what is happening. You know, you have, this is this is M1, this is M2, and this is the intermediate main term. So now just see something different happens. So what is happening is, see over here you have, okay, so first of all let us consider, let us consider this as transition 1, and let us call this transition 2. Let us look at transition 2. With transition 2 there is really no problem, because what is your change? Oh, okay, let us call this M4. So transition 2, what happens? This is so what are the cubes that are involved? You have, let us call this C1, let us call this C2, let us call this C3. All right. So if you consider what is happening, so here it is going through M1, M2, sorry, M1, M4 to M2. And what is happening? You have C3 is 1, C2, C3 are 1, then here only C3 is 1, and here nothing is 1. Alright. So this is a nice situation, no hazard. No hazard, but consider what happens for transition T1, that is this transition. Consider what happens for transition T1. So here you have M1, here you have M2, here you have M3, right? Here you have M3. So here what is happening is, when you are in M1, C3 is high, right? Let us say C3 is high. All right. When you are here, C2 is high. Okay. So here C2 is high here, it is high here. See what happens with C1. C1 is low here, it is high here, and then, so let me draw C1. So mind you, this is, highly magnified time scale. This is highly magnified time scale. This one, highly magnified time axis. So I'm drawing, two, two waveforms for C1. Both can happen. So one waveform is more benign. One waveform is more benign. But you can have another waveform which is problematic. So let me draw it here. All right. So both are possible waveforms for C2. These are possible waveforms. For C1. These are possible waveforms for C1. So this one is okay because, if you look at the effect of this, the overall waveform will, just change from 0 to 1 over here, okay, overall waveform. But if you look at this one, if you see the effect of this black and the red, so let me just draw so I think you can also construct it on your own. So the overall effect of these three waveforms is actually like this. What is the overall effect? Can you sketch it? So the overall effect is like this. Basically, I'm just drawing it in magenta. The overall, oh sorry, I thought I chose an orange. So the overall waveform is, this is, I'm saying, okay, this one is really like this. This is the overall waveform. This is the overall waveform. Okay, so what is happening is that here you can have a glitch. This is your glitch. Oh. This is your glitch, okay? So what is happening? Just try to note that this is a highly magnified time scale. So C1, this one is, you can say, let me write that in red itself. Here, C1 is slow. C1 is slow. So what is happening is, C1 is coming on, but it's coming on slowly, okay? So it's coming on slowly, and say C2 is fast. So C2 goes down fast because C2 is making only a 0 to 1 transition, but C1 is making a 0 to 1 to 0 transition. Note that this is making a 0 to 1 to 0 transition. Okay, these are more complex transitions. C2 is making a 1 to 0 transition. C3 is also making a 1 to 0 transition. Okay, so it is C1 which is making a 0 to 1 to 0 transition. And if the gate is slow, that means instead of the transition happening something like this, like the one shown in green, if it happens like this, this is, this is, let us say, where is that green? Okay. So green, this is also fast. Or that one is probably light green. This is also. So if C1 is a fast gate, there is no problem in this case. But if C1 happens to be a slow gate, then you get a hazard, as you can see. Oh, sorry. Yeah. So this is the glitch. This is the glitch. So if C1 is slow, then you get this glitch. All right. So this is. So if you think about it, so this is called an illegal intersection. So if you think about just this transition, this presence of this cube is not really needed. It was not needed. So this is called an illegal intersection. So let me just. Can't really see anything like this. Is this any better? This is called illegal. Illegal intersection for the transition. All right. So if you did not have this illegal intersection, then you would not have this problem. So now, of course, you find that different transitions give rise to different requirements. So that's a problem. That's really a satisfiability problem. But we studied the situations one by one. So this is a transition. So this is for a, as you can see, for a 0 to 1 transition. This is for a 0 to 1 transition, and what you have is there is an illegal queue for the indicated indicated 1 to 0 transition. This is what we have discussed now. All right. So if you had restricted it to just this much, if you had restricted this cube to just this much, then you would not have this illegal intersection for this transition, all right, and then this hazard would not have been present. So this is an important concept. Okay, this is an important concept. All right, I think we'll have to stop here now. I would request one more class. Can you find a slot tomorrow for an extra class? We can I mean, that is a bit tentative, but still we may or may not need that. So can you identify a slot for an extra class tomorrow? You have a regular class at 10 o'clock, of course. When I will not be available, unfortunately. So can you identify an extra slot in case we need it? Yeah? Say something. Are you writing something in the chat or what? Where's the chat? Oh, I'm not very good at finding things. Oh yeah. When can you have an extra class tomorrow? You have
6 p.m.
Sorry, 6 p.m. Okay. So 6 p.m. let us have one slot. We may or may not use that. That will be confirmed in the class tomorrow. So for now, let us. There is a instead of no, it is not instead. It is in addition to the regular class. In addition to the regular class. Yeah. Okay. So let us have an extra class tomorrow tentatively at 6. So we'll see. We'll have to see the situation tomorrow. Either Professor Mitra will complete this tomorrow, or we might. It may be desirable to have that extra class. So tentatively, let's have it. All right, then we'll stop here now. I think we can stop the recording. Okay.